Yes, so today what I need to discuss, okay, I need to discuss about, okay, so लास्ट वीडियो तक हमने सोल्यूशन तो नहीं बनाया था, हमने डायरेक्शन फील्ड्स प्लॉट किए थे और जो सोल्यूशन हमने पेन एंड पेपर में बनाया था उसका प्लॉट किए थे बस. एंड वी फाउंड दैट द डायरेक्शन फील्ड्स आर टेंजेंशियल टू द सोल्यूशन, ओके, द सोल्यूशन कर्व. ठीक है, इतना तो हमें समझ में आ गया था. बट नाउ व्हाट इफ वी हैव अ फंक्शन कि जिसका सोल्यूशन हम पेन पेपर से नहीं बना पा रहे हैं. ओके, फॉर सच ए केस यू हैव टू यूज something known as a numerical method for first order ODE. Okay, and that comes to be this method. Okay, range kata method, whatever, kuta, range kuta method. Okay, fine. Okay, so I want to discuss this. So the blue one is the solution of the differential equation we got using pen and paper, and this is the range kata method solution, right? Anyways, so what is the observation here? There is error. Okay, and the solution that we have got using our computation is not following the exactly following the those arrows, the direction fields, those direction fields. Okay, तो ये conclusion है कि there are certain amount of error in numerical computations and they will be there. Okay, and we cannot reduce it without a lot of computations. Okay, and this method supposedly doesn't remove the error if we have enough computation also, because all these things are just approximations. Fine. So if that is the case, then we have to deal with what we have, right? So from where do we start? This code is something that I have written. Okay, I hope that you have tried it yourself. And this code, this is I have written without telling you, and I hope that you will get it. These are, I will provide you references to the topic of solving first order differential equation, and this is the method. Okay, what exactly we are doing? Nothing serious. Okay, so this is something that is finding the change in y. Okay, this is finding the change in y with some manipulation, right? Okay, so we are taking the initial change and we are dividing it and we are finding some other point. Fine. And we do compute in this fashion. So this f function is nothing but our differential equations. Which side? Left side or right side? Right side. Okay, y dash is equal to some function of x and y. So this is that function, and we take the average of that, 1 by 6 k1 plus 2 times k2 plus 2 times k3 plus k4, and we find the new y value which depends on existing y value, the yn plus 1. This is the yn plus 1 term. Okay, and we insert that yn plus 1 term into the array. Fine, and then we have the curve. So now can we solve second order differential equation? Yes. So let me tell you about the theory of second order differential equation really quickly. Okay, so do we know about second order differential equations? कैसे होता है इसका form? So it will have a y double dash term, okay, d square y by dx square, fine, plus some some function of x, let us take it to be 0.5, maybe 0.5 y dash plus 0.1 y is equals to x. Okay, let's suppose this is the differential equation, but it can be applied to any differential equation. That is not the issue here. But can we solve this? How do we do that exactly? So can we do some trick to reduce it into two first order differential equations? So if that is the way of doing it, please, that is the way of, right. So the way of doing it is from a generalized case, which is first order system of first order ODEs, okay, system of first order ODE. So this topic I will not cover. I hope that you will able to study that, but what I am going to show, so I am going to show you a trick, okay. So I will call y as y1, okay. So if I do that, what is y1 dash? That is y dash, and I will call that y2. So what is y double dash? That is nothing but y2 dash, and that is nothing but y1 double dash, okay. If I make this appropriate substitution in the above equation, what is going to happen? Can I say y2 dash plus 0.5 y2 plus 0.1 y1 is equals to x? Yes, so I can say that. And can I say y1 is equals to, or can I say y2 dash equals to y1? So these are the things that I can see clearly, okay. y2 dash is equal to y1, and also it so happened that y2 dash is this equation. So I have two equations. So equation 1 and 2. This is the system of first order differential equation. So I did something wrong, I guess. Yes, I have done something wrong. So this is nothing but y1 dash is equal to y2. Fine. So I did some mistake, but this is the whole story. So can I write the equation in the matrix form? This looks really nice, but let us see. So these are all dash, y2 dash, y1 dash. Put it in a matrix or vector, right? And what do we have? You have minus 0.5 minus 0.1, okay, and you have 1 and 0. Fine. And this is nothing but y2, and this is nothing but y1, and then I have 1 comma 0 x. Okay, so can I name all this matrix? This is a vector, only one column matrix, so I can call it yn. Okay, dash vector is equals to, I can call this as a matrix, y vector yn vector plus b vector into x vector. Okay, so this is a compact representation, but how do we solve this? So that is the question. The important question remains, how do we solve this? So how do I go about solving this? Yes, so ठीक है, तो आप ऐसे सोचिए कि y1 फंक्शन के लिए y1 n plus 1 is equals to y1 n. Okay, so this is something we know. A function's next value is nothing but dependent on function's current value. ठीक है, ये तो हमें पता है. Plus step size times some function of x, right, xn comma y n. But what is this y here? I have to give a subscript. You can see this as y2. Okay, fine. Can I write something about y2? y2n plus 1 is nothing but equals to, yes, y2n, okay, the current value and the function of depending on xn. It also depends on y2n and it also depends on y1n, right? So that is the situation we have. Okay, and then what can we do? Can we expand this? Right, no more expansion required. We know these functions. To distinguish, I will call this function 1 and this is function 2, right? So function, if I am not able to make it clear, the function 1 is nothing but y2 and the function 2 is nothing but, what is this, minus 0.5 y2 minus 0.1 y1 plus x. If I take the whole thing away, that is how we were writing first order differential equations. Okay, so f y dash is equals to some function of x comma y. Here what is the case? Y dash is replaced by yn dash and f n x comma y, right? Obviously I have to write in terms of n. Okay, so it also depends on other n's. Okay, this has to be a vector form. Fine, these are all vector functions. So this is something you can see. If you have knowledge of linear algebra तो ये समझ में आएगा. Otherwise I am trying to explain you in a crude way. What is the crude way? Initial conditions are also required. So initial condition, what is given? So initial condition is given y of x naught. Okay, x naught is given, y of x naught is given, and y dash x naught is given. So these are the initial conditions that I have. what are these initial conditions? In our modified way of writing, this is nothing but y1 x naught, and y dash x naught is nothing but y2 x naught. okay, ठीक है, these are given, that's why in the green they are. So can I compute yn plus 1, right? That is y1 value for x is equal to x naught plus h. That is how we were doing. X n plus 1 is equal to x n plus h. Okay, so for a new x value, can we find a y1 value for y1 for a new x value? Yes, because we know what is y1 x naught or y1 n is known to us. We know this function because we know this function is nothing but y2. We know y2 x naught. Okay, this is known to us. Once we know that, can I find y1 n plus 1? Yes. If I know y1 n plus 1, can I find y2 n plus 1? I can find. Okay, if I know y2 n plus 1, can I find y1 n plus 2? Fine. So if you know y2 n plus 1, you can find y1 n plus 2, because it depends on y1 n plus 2 depends on y2 n plus 1, which we have found, right? So it's a chain reaction. If I know initial condition, I can find y1 n plus 1. okay, this can be found by the initial condition. If I know that, I can find this. If I know that, then I can find the next y1, that is y1 n plus 2, and so on, and I can complete the y1 array. And if I complete the y1 array, this is nothing but y, and y is our solution. So y is solution. So shall we go and code this? Yes. So please be patient, and you would understand this. So can we start with the Jupyter notebook? Okay, let's go ahead. The regular import statements: import numpy as np and import matplotlib as matplotlib dot pyplot as curve. Okay, so how do we get started with our problem? So let us write the differential equation. So that is y double dash, okay, plus a times a can be a function of x, function of xy, whatever, and y dash. Okay, so a is some function of, it can be constant. Okay, if it is a function of x, then we have a linear differential equation. Okay, if it is a function of y, then we have a non-linear differential equation. ठीक है, तो depending on coefficient of y double dash, y dash, y, we can term a equation as linear or non-linear. But ये method for the all possible case. Okay, linear, non-linear, every case is covered here. So can I again write like this: b times y is equals to, so I'm just showing you the differential equation. This is not valid statements. Okay, is equals to some function of x comma y. Okay, so how do we start? Let us create our differential equation. The differential equation is going to be y double dash plus, let's say, 0.5 times y plus, okay, 0.1 times, sorry, this is y dash, 0.1 times y is equals to, let's say, 5. That is pretty much understood. Okay, so that's 5 okay, 5, it's okay, good enough, or 0.5, right? So if that is the case, how can we go ahead? So can we replacement like y1 dash, okay, is what? Y1 dash is y2, that we know. Okay, what is y2 dash? Y2 dash is negative 0.5 y dash, which is nothing but y dash is, yes, that is y1 dash. Okay, 0.5 y1 dash. What is y1 dash? That is nothing but y2. I don't want to write in terms of dash anymore because we have y2 dash here, no more dash. Okay, and y 0.1 y is nothing but y1. Okay, y was y1. Okay, y1 is y. ठीक है, तो this is the case we have. So is it a first order differential equation in y1? Yes. Is it a first order differential equation in y2? Yes. So how can we find the solution? It is simple. The solution is given by what? We have seen. I will write the solution. These are now valid statements. Okay, these are comments. So these were all comments. These are not valid statements. Okay, next, can we start with the initial conditions? Yes, y1 not is something, y2 not is something that we don't want to put it here, but these are initial condition. X naught is something. Okay, having set the initial condition, what do we do? Can we write the differential equation solution? Yes, we can write the differential equation solution. So what is the solution? The solution is of form y1, okay, so y1, how do we want to take the solution? As an array. Okay, so np dot array. What is the initial value of the y1? That is y. We know y1 not 10. Okay, done. What is the initial value of y2? Y2 is also a variable of interest for us. ठीक है, तो y2 का वैल्यू क्या है? इनिशियल y20. डन. ओके, and we also need a array x. np dot array x naught, initial value of x, from where we want to start our computation from. Okay, h, step size we need to specify 0.002 maybe. We can check that later. Fine. So What else? Now shall we start with algorithm? For I in range, what does this statement do? Nothing but whatever below statements are that are going to run for 100 times. Okay, so we are computing the solution at 100 points. तो for loop कहते हैं, this is known as for loop. So if you have not very clear with for loop, you can go watch a YouTube video. Okay, so I wanted to make a series on basic Python, but I don't have that much of time. Okay, anyways, I'll try. If I do that, I will put all the necessary prerequisite link video below every video that are in this playlist. Okay, but anyways, this is a for loop. Okay, fine. Runs 100 times. So what do we want to do for all the 100 times? Can we compute y10? Okay, y10, what is this? y10 underscore np1, what I have written. Basically this is y10 computed at n plus 1. It depends on y. Okay, y I have written 10, it is better written as y1. Okay, y1 np plus 1, y1 at np plus 1. What is the value? It is nothing but the value of y1 at I. Okay, so and then plus h times. So by Euler method we can also use the Runge-Kutta method, but not right now. Okay, fine. So let us make things easy. I'll write a program for that and I'll post you the GitHub link for the Runge-Kutta method. Okay, same implementation. But as of now, in 2, what do we have to do? So y1 dash depends on a function that is y of 2. That is y2, not y of 2. So that is y2. Okay, so can I say y2 is an array and it depends on at which instant I am computing, right? So that is pretty much understood. Okay, fine. So let's say if this equation is not understood, put I is equal to 0. If I put I is equals to 0, y1 n plus 1 is nothing but y1 value for I means index 1. Okay, for I is equals to 0, I have computed y1 for index 1. Then I have to append this value to y1. So y1, how do I append? So it happens that np gives us a function known as insert. Okay, don't use the append function. There happens to be append function also. तो append function हमको use नहीं करना है, insert function करना है. तो first argument is which array on which we are inserting, that is y1. What is the index that we are inserting? I plus 1. Why I plus 1? That you need to find out. Okay, these are logical things. I plus 1 इसीलिए क्योंकि obviously आप जिस इंस्टेंट के लिए कंप्यूट कर रहे हैं y फंक्शन, राइट, लेट्स से 5th इंस्टेंट के लिए आप कंप्यूट कर रहे हैं, वो तो 4th इंस्टेंट पे डिपेंड करेगा, राइट, टिल नाउ. एंड इट इज़ ऑब्वियस दैट y1 एरे में 4 नंबर्स होंगे, तो 5th वाला जो नंबर होगा वो आपने कंप्यूट किया है. ओके, इफ यू आर एट द 4th इंस्टेंट एंड यू आर कंप्यूटिंग फॉर द 5th instance, then n so you have to write the index as n plus 1. Okay, 0th इंस्टेंस का हमें पता है, ओके, दैट इज़ द इनिशियल कंडीशन, और x नॉट 0, लेट सपोज x नॉट इज़ 0, तो 0th इंस्टेंट का हमें पता है, फर्स्ट इंस्टेंट का ही हम इंसर्ट करेंगे एरे में, तो दैट इज़ द लॉजिक बिहाइंड इट. व्हाट इज़ द वैल्यू? y1 underscore np1, right? And optional axis is equals to 0. What does this means? This means that we want to insert everything on a single row, okay? So numpy ka I will have a different series of lectures. Anyways, ठीक है. तो you can also understand numpy by the documentation. That is not very difficult, but ठीक है, मैं भी एक वीडियो बना दूंगा बेसिक्स ऑफ numpy में. तो np.insert done. It was not difficult at all. Once we have yn plus 1, can we say anything about y2? Okay, no, y2 plus 1, does it depends on yn plus 1? Not really. Okay, so let us see, it depends on yn only. So let us see, y2 n plus 1, np1 means n plus 1. What is this? Let's say we have this differential equation, so this is nothing but it is y2 I plus h times, okay, minus 0.5 into y2, okay, minus 0.1 into y1 plus 0.5. Is that clear? Okay, if that is the case, I have to insert the y2n plus 1 value here, copying the same statement, but our array is now y2 and our value is y2n plus 1, axis is 0, index is same, right? We also have to append to this array. So why is this? Because as we keep counting, we have to increase the x array so that we can plot. How do we plot? We need an x array for that, so I am doing that. What is the array that we want to append to? X, index I plus 1, and value is h times I plus 1, depends on which instance we are, and then we multiply h so that we have the appropriate x value. So that is the case, and it so happened that we have to write y1 here because y1 will not be updated. That is how numpy works. I wish that numpy could have done it without me reassigning, because I have written np.insert. Okay, it should directly affect the array, but that is not the case. ठीक है, तो now we are pretty much on it. Can we check again? Can we understand this? So y1 depends on y2. For that we know that y2 not is given to us, y1 not is given to us. तो दोनों मालूम है, h मालूम है, y2 not for x is equal to 0. We can find this. This value is nothing but y1 value for x is equals to 1. So we have inserted that, okay, on the array. Great. And then y2 depends on y2, okay, y2 at that instant, okay. So I have written y2 here, okay, that's wrong. So this is y2i and this is y1i, and here it's right. Fine. Okay, so that was wrong. So y2 arrays ith element, and this is y2 arrays I plus 1th element. ओके, तो y2 एरे का फर्स्ट एलिमेंट मिल गया, y1 एरे का फर्स्ट एलिमेंट मिल गया. ओके, विद द हेल्प ऑफ 0th एलिमेंट. तो y1 एरे का second element will depend on y2 array ka first element, which we have computed on the last step, and that we can get from here, this statement. Okay, so this depends on last computation of this. Okay, so that was pretty much it. But matplotlib we know how to plot, I guess. तो इतना सारा practice हो गया होगा and we know how to plot. How do we plot? We need two objects. We will get two objects, therefore two variables, fig and ax, axis, and curve was our name dot subplots. Okay, ax dot we want to plot now. And what are the values? X comma y1, not y2. Okay, and curve dot show. Fine. Can we go ahead? No, we cannot, because we have not provided the initial values. Initial values are to be provided. Okay, we can provide any initial value for that matter, right? So please provide the initial values as decimal points, otherwise things won't work. In my case it's not working. Why? I don't know. That is something to do with numpy d type. I will have to check it. Okay, anyways, okay, so can we go ahead? Right? Okay, let's try. Can we get the result? Fine. Okay, so we want to explore the nature of it. So can we compute 200 points and see what happens? Nice. Can we compute for 10,000 points and see what happens? Nice. So we are knowing a lot about the curve. The curve is stagnant, dips down, goes up. Can we compute for 1,00,000 points? Or not doing that, I'm decreasing this. Okay, so this is how it is behaving. Okay, so there is another differential equation for which I wanted to find the solution. Okay, because the solution is given in this book. So it happens to be a sinusoidal wave, and you can find out the solution easily. So it damps to nothing at 20. Okay, so it oscillates and damps down to nothing. तो ये एक homogeneous differential equation है जो आप solve कर सकते हैं बुक से. I am using this book, ये वाला बुक जो हर colleges में use होता है. Okay, अर्विन क्रेजिक, KREYSIG, अर्विन क्रेजिक. तो ठीक है, तो डिफरेंशियल इक्वेशन में लिख देता हूँ जल्दी से. डिफरेंशियल इक्वेशन है -0.4. सो आई एम मेकिंग एप्रोप्रिएट चेंजेस. ओके, हर जगह चेंज नहीं है. इनिशियल कंडीशन में चेंजेस है और कोफिशिएंट में चेंजेस हो गए. ठीक है, एंड दिस इज 0. फाइन. What are initial conditions given? Y dash is y dash of 0 is 3. Great. I have to give point. Y dash y of 0 is given 0. So 0. Okay. Can I get the solution? So if the function, if the the solution is correct, the algorithm is correct, then I should have a function which oscillates, starts from 0, ends at 0 at x is equals to near about 20. Right? Okay, so it is oscillating, and does it die down to 0 at about 20? How can we know? We don't want to plot for all these points. We want to reduce, and I want to plot till 20. So it almost die down at 20, but can we have it till 25? Okay, 25, it should be 0. 25, how do I make it 25? Okay, I have to place 5 here. Fine. So this was the curve. You can check this curve for the differential equation. I guess it's not visible. Maybe if I can increase the size, perhaps some better. Right? This is how it looks. This is faded, but okay. Anyways, that is correct. You can check the algorithm. If it is wrong, write on the comment box. Thanks for being there. Okay, thank you.